Hi everyone, today we're going to have a look at a contemporary study in the cognitive approach in AS psychology. So, a contemporary study is basically just a fancy word for a more up to date psychological study, okay? And each approach will have a classic and a contemporary study. So, your contemporary study for the cognitive approach is the study of the development Pattern of Digit Span by Sebastian and Hernandez Gill in 2012. Okay. So firstly, we're going to start off by doing a little task, okay? And I want you to take part in this task as well. So what I'm going to be doing is I'm going to be testing your memory or your digit span. This is going to involve me reading out a sequence of numbers, which I would like you to recall back or write down on a piece of paper. Okay, so each time I say a sequence of numbers, for example, 5, 6, 3, 7, 2, I want you to, I'll give you a couple of seconds and I want you to write down that number, okay? And then at each time, I'm going to add an extra number on, okay? So the digit span sequence is going to get a little bit longer every time, okay? So here goes. So 2, 5, 9, 4, 5. Write it down. 3, 7, 8, 1, 6, 9. Write it down. 9, 6, 1, 5, 2, 6, 8. Write it down. 4, 3, 7, 5, 9, 2, 1, 5. Okay, so what I want you to do is I want you to look at the digits that you did recall correctly and if you did forget any, okay? The aim really of this little task was to show you what Sebastian and Hernandez Gill did in their study. So they obviously tested memory of digit spans. So a little bit of background to the study. Sebastian Hernandez wanted to investigate the phonological loop, which was part of the working memory model. So just go back through that, if you don't remember the working memory model, because it's quite important to understand that theory before we go through this study. So the phonological loop is obviously the part of the working memory that deals with sound, okay? So the auditory information, how we process that. So what Sebastian and Hernandez wanted to test was the capacity of the phonological loop using verbal digit span, so number sequences. And what they wanted to do was measure the capacity by the number of digits that a person remembered. Okay, so they wanted to look at and confirm really findings of some of the previous research that has been carried out, which suggests that digit span increases with age, and then after the age of about 15, it tends to level off, so it doesn't increase any more than that. Right? So the aim was to test the phonological loop in children between the ages of 5 and 17 years using a digit span as a measure of phonological capacity. Okay. So we wanted to really see if digit span increases with age, as previous research has suggested. So the method itself, so got 575 participants, quite a good sample size, taken from 13 different schools in Madrid in Spain. And participants were aged between 5 and 17 years old. They were divided into 5 different age groups. So we've got preschool, which is 5 years, primary included 6 to 8 years, primary 9 to 11 years, secondary 12 to 14, and secondary 15 to 17. Okay. Data on all the children was collected to ensure that they did not have any hearing disorders or any other reading and writing difficulties or any other learning disabilities or impairments. And this was done by asking parents of the children. So the task involved the researcher reading out a sequence of digits, as I did at the start to demonstrate, and to recall in order. Okay. Participants had to listen to the digit sequences being read out, and then they were asked to repeat it back in the exact same order. The digit span was recorded as the longest sequence which the child or the participant could recall correctly in order. So if they correctly recalled 5 digits in order, then their memory capacity was recorded as 5. The results. So the average digit span for each group was the following. So preschool, which is 5 years, the digit span was about an average of 3.62. That's that's how many numbers they recalled in correct order. Primary 6 to 8 was about 4.34, so obviously an increase there with the age. Going to 9 to 11 years old, 5.13, so again it is increasing. And then 12 to 14, 5.46, so again it's increasing there. And then secondary, 15 to 17, very slight increase, not much, 5.83. So what the results really show is that digit span does increase with age, which is what was expected, and previous research has also found this. Children aged 5 had a very low digit span that increased steadily up to the age of 11. Between 15 and 17 years old, you can see there's not much difference, and the digit span did remain pretty stable between those ages. These findings were compared with earlier and previous studies on the digit span and capacity of elderly people. So the findings showed that elderly people actually had a higher digit span than 5 to 6-year-old children, which you may not expect really. Okay. Also, this study did look at a group of elderly people that had dementia and Alzheimer's. So dementia and Alzheimer's are both conditions which affect the memory, so they impair the memory really, so that a person can't remember much information. And what they found was that results were very similar to the group of healthy elderly people. You would expect dementia and Alzheimer's to have a worse memory, but in fact, the digit span was quite similar to the healthy group of elderly people. In conclusion, then, obviously this study was carried out in Madrid, so Spanish children. The digit span increased with age up to the age of 17, whereas Gathercole and Alloway in 2008 they conducted a very similar study, but obviously in the UK, in England, and they found that a similar pattern was seen where digit span did increase with age, however only up to age 15. The average digit span was, however, lower for Spanish children compared with English children. So, what could be the reason for this difference? Well, Spanish words for digits are longer than those in English. For example, we say 1 in English, Spanish is uno. So, 1 is 1 syllable word, uno is 2 syllables. So the Spanish words for digits actually occupy more space in the memory, and they take up more of the capacity than the English words. So this might be a reason which explains why the digit span was lower for Spanish children compared with English children. Evaluation of the study. The study was standardized, so obviously the digits were read out aloud at a rate of 1 digit per second. So, having careful controls like this makes the study a lot more valid, okay, because we've got a lot more control of the study and different factors. Children were not cognitively tested directly because obviously the data was gained from parents, and this may not have been accurate. So parents may not have been aware if their child had a cognitive impairment. So this, again, questions of validity. The task of recalling increased digits is not a realistic task, so it's not a task that we do every day. Therefore, it can't really be applied to real life. The study can be used, however, to explain why people with longer digits tend to be better readers, whereas lower digit spans tend to be more likely to have a specific learning disorder. Okay, so again, studies like this do help us in psychology to really identify children's learning abilities early on. A large sample of participants was used, and again, a variety of ages were tested, which makes the study a lot more generalizable. Okay, so these are only some of the evaluation points. There are many more evaluation points, so do have a read of the textbook so you can get some more evaluations written, and go through the PowerPoint again, go through the aim, procedure, results, conclusion, etc. Okay.